Hi everyone, so this is going to be part 2 of our acid-base neutralization reactions. So if you've seen part 1 and you're ready to see more complex acid-base neutralization reactions, you're in the right place. If you haven't, I would suggest you go to part 1, because what part 1 does is it explains what's an acid, what's a base, what's an electrolyte, and how acid-base reactions happen and what their products are. So if you are still unsure of those things, I would highly suggest you see part 1. Now, to recap, there was 3 key things that we talked about in part 1. The first thing that we talked about in part 1 is that acids, bases, and salts are electrolytes. So what does it mean to be an electrolyte? Well, it means that when it's dissolved in water, it produces ions. Which brings up to point 2. So when acids, bases, and salts are dissolved in water, they form their ionic forms. So that means ionic forms. That means charged. So acids, bases, and salts, they all do this. That when they are dissolved in water, they form the charged ions. So for example, let's say we have HCl, which is our classic acid. When it's dissolved in water, it separates into our hydrogen ion and our chlorine ion. Same thing with sodium hydroxide. When that's dissolved in water, it dissociates into our sodium ion and our hydroxide ion. So if we'll notice, all of our ions have either a positive sign or negative sign. So this has to do with if it's either gaining an electron or losing an electron. So if it loses an electron, it will have a positive charge, and if it gains an electron, it has a negative charge. So losing electrons, those are normally your metals and hydrogen, and gaining an electron, those are normally your nonmetals. Lastly, and this is the most important thing that we talked about in the last video, is that acids and bases, when they react, form a salt and water. And where does the salt and water come from? Well, let's say if we were doing our classic example of hydrochloric acid, it dissociates into H plus Cl minus. And if we had sodium hydroxide, it dissociates into Na plus and OH minus. And as we said in the last video, basically what's happening is that the ions are doing a partner swap. So that means our positive ion here is going to change the negative ion it was attached to. And our positive ion here is going to change to a new negative ion. So in this case, our hydrogen ion is going to form a bond with our hydroxide group, and our sodium ion is going to form a bond with our chlorine ion. So this produces H2O, because we have 1 hydrogen, 2 hydrogens, and 1 oxygen, which is our water, and our salt of sodium and chloride. And remember, a salt is basically any molecule that has the first component is a metal and the second component is a nonmetal. Now, what we're going to be doing in this video is we're going to be looking at more acid-base reactions when the charges are not a 1-to-1. So in this case, our charges are 1-to-1, because if we look at it, For our hydrogen, it's a +1 charge. For chlorine, it's a -1 charge. For our sodium, it's a +1 charge. And our hydroxide ion, it's a -1 charge. So when we formed our new molecules, we didn't have to actually worry about the numbers, if we had to have more of one than the other, because they work out perfectly. What we're going to be doing in this one is we're going to be looking at acid-base reactions when the charges are not the same. And we're going to see how do we figure out what molecules are being made. Okay, so the reaction that we have is we have with this molecule right here and this molecule right here. So our first molecule right here, this is actually sulfuric acid, and we know it's sulfuric acid because we have our two hydrogens, and our hydrogens are not connected to our oxygens. As we see over here, we have the one hydrogen connected to the oxygen, so this forms a hydroxide ion. So this molecule is KOH, which is our base. We know it's a base because it has an OH. And this molecule is H2SO4. It starts with a H, so this is our acid. So in our first acid-base reaction, we have sulfuric acid and potassium hydroxide. So again, this is what we have, sulfuric acid and potassium hydroxide. So what we're going to do is we're going to actually look at this in our ionic forms. So this is basically our sulfuric acid is right here in its ionic form. So H2SO4, and what we have over here is our potassium hydroxide in its ionic form. Now, first thing that you'll notice is that our overall charge of our sulfate ion is -2. Now, remember, key thing is in the molecule, the net charge needs to be 0. So, for your net charge to be 0, you need to have your positive charges. When you add them to your negative charges, it gives you an answer of 0. Now, we had 2 hydrogens in our molecule. Each hydrogen has a +1 charge. So overall, we have, for our positive charges, is +2. Now, ask yourself, what number minusing 2 will give you 0? And that's right, the only number that you can have is -2. So that's why this molecule right here, this polyatomic ion, has a net charge of -2. So there's 2 ways you can do this. You can either look at the number of hydrogens and work backwards to figure out what your charge of your sulfate ion is, or you can just remember that. I personally like to work it out, because then when you do your double checking, you'll notice that you have all of your charges equal to the same amount. But it's whatever you prefer. And then on this side, we have, it's a simple 1-to-1, where we have our hydroxyl ion is a -1, and our potassium is a +1. So I'm just going to erase this, and we're going to continue. Okay, so just like last time, we're going to be doing our partner swap. So our hydrogen is going to go with our hydroxyl group, so that's fine. Now, we're just going to move this up. Our potassium ion is going to go with our sulfate group. Now, let's double check. Right here, we have +1, -1, that gives us 0. So this is done. Over here, we have +1, -2 gives us -1. Uh-oh. Problem. We are missing one more positive ion to counteract the negative ion. And if we look right here, we're also missing a hydroxyl group. because the name of the game is we want all of our molecules that we make to equal to 0. So what we need to do for our hydrogen ion to have another hydroxyl group, so it can make another water molecule, and for our sulfate ion to get another potassium, so it can have a neutral molecule, that's right, we're going to have to bring in another potassium hydroxide and have it dissociate. Okay, so we have our another potassium hydroxide, so now we can just finish our problem. We have our potassium, come on in. So now let's redo our math here. We have, let's scratch this out. So we have +1, +1, -2, which gives us 0. So this is balanced. And this is finalized. And this makes the molecule, well, let's count it. How many potassiums do we have? We have 2. So K2 and our SO4 molecule. Now we're going to do the same thing with our other hydroxyl ion and our hydrogen. Bring this over. We're going to do our math. 1 + 1 - 1 gives us 0. So we're done. And how many water molecules do we have here? Well, we have 1 water molecule. We have 2 water molecules. So we have 2 H2Os. So if we're writing down our balanced chemical equation, it should look like the following. So our balanced chemical equation is 1 sulfuric acid, H2SO4, plus 2 potassium hydroxides gives us 1 potassium sulfate and 2 water molecules. And remember, we needed 2 potassium hydroxides because our SO4 had a -2 charge. 1 potassium has a +1 charge, so the only way to get a +2 charge is to have 2 of those. And just because we have 2 potassiums, that means we have 2 hydroxides. And you'll notice right here, we had 2 hydrogens. Now, one hydrogen is +1, the other hydrogen is +2. And as a result, we get 2 waters. Now, in our next example, we're going to be doing another acid-base reaction where the ions are not a 1-to-1, but in this case, we're going to be doing one with a 3-to-2. It's the same process, but it's a little bit trickier.